Okay, and in the second problem, it's a linked data problem. Second problem, we need to find out the power dissipation across the dependent source. Power dissipation across the dependent source 3IAX. So to find out the power dissipation across the source, we need to find out the value of the current flowing across the source and voltage. The voltage across the dependent source 3IAX is a 3IAX actually, and for that voltage source, to find out the value of voltage source, the only thing we need to find the to find out the voltage, we already know the potential of VA and potential of VB. So by subtracting VA and VB, we can find out the potential. And but the first thing we need to see that we need to find out the value of IX. What is the IX? IS is defined as 5 minus VB by 10. Right now I know the value of VB because I have just calculated the voltage of VA, VB, and VC. So my IX is 5 minus VB by 10, which is 5 minus 7.41 upon 10, is equal to minus of 2.41 ampere. The minus sign signifies that actually we have assumed the direction of Ix incorrectly. In the question, the direction of Ix is given incorrectly. Actually, the current is flowing from node B2 towards 5 volt, but in the question it is given that Ix is flowing from 5 volt to node B. So that's the meaning of minus sign. So now, if you have look at the circuit, you can see that from this 4 ampere current source is flowing the 4 ampere current towards the node B. It's moving inside the node B, and the Ix current is also flowing inside the node B. The 4 ampere current is also coming inside the node B. So if we apply the KCL at node B, I can see that if I assume the current moving out from the node B, the current is moving out in the branch of 3Ix. So the KCL says that the sum of the incoming current is equal to sum of the outgoing current. So current flowing across 3Ix is equal to the Ix plus 4. Because this is my moving out current, and my outgoing current should be equal to the incoming current to satisfy the KCL here. So if I may apply the KCL at node B, so I can find out the current across 3Ix is Ix plus 4. So we can write it down here as the current flow in dependence in the branch of dependent source is equal to 4 plus Ix, where we know that Ix is actually minus 2.41. So this current across 3Ix is basically 3.759 ampere. We need to find out the power dissipation across the current source. So power dissipation across the dependent source will be voltage difference, which is VB minus VA into the current I3Ix, which we have just find out. VB is given as 7.41 minus VBA is 6.44 and current is 3.759. So this is nothing but a 3.64 watt. So power dissipation across the dependent source is 3.64 watt. So that's all from this question. This is a very good problem which we did, in which there are 3 nodes are given, which is just related to the battery source. There is no resistive element is present. That's why we are able to apply the super node. But if we apply the super node, then this problem is simplified, because we can find out the one big relation. We can apply one KCL across node A, B, and C with the help of super node, and then by the inside this super node we can find the one relation between node VA and VB, and one relation between VA and VC, and Ix current is defined as the current flowing in the branch of BD. By these 3 relations, I can find out the potential of node VA, VB, and VC. And if once I can find out the potential of VA and VB, VC, I can easily find out the value of Ix. and then after that with the help of the KCL at node B, I can find out the current flow across the dependent source, and which leads to me towards the value of power dissipation across the dependent source. So that's all from this question. Thank you.